Okay, so our project is a simple regenerative braking model using brushless DC motor. So first let me give a description of the components that we have used to implement our project. So here we have an Arduino Uno microcontroller circuit. Here we have an electronic speed controller that controls the speed of the brushless DC motor that we have here, and in this entire setup we have two power supplies. Firstly, a 9-volt battery that supplies power to the Arduino Uno, and secondly we have another 12-volt lithium polymer battery that powers the electronic speed controller that controls speed of the DC motor. And for storing the power that we generate while braking the DC motor, we have a rectifier circuit that is in parallel with a capacitor and an LED light, just to demonstrate the usable electricity that we can generate while braking this DC motor. And we have two switches to demonstrate our braking mechanism, and finally we have a potentiometer connected to the input terminal of the Arduino Uno to regulate the frequency of the signal that will go into the electronic speed controller. Now I'm describing the working procedure of our project. The Arduino Uno controls the pulse width modulation frequency that is sent to the electronic speed controller. So by rotating the potentiometer knob, we can control the pulse width modulation frequency that the Arduino Uno sends to the electronic speed controller circuit. So we can actually demonstrate this by rotating the knob in the potentiometer, and thus we can see that the speed of the brushless DC motor is changing gradually. And we know that while rotating, a DC motor creates a back EMF, generates a back EMF, and it's this back EMF that we will ultimately use to bring the motor to a stop. And we have actually stored this back EMF in a capacitor bank that is connected in parallel to the circuit. So here we can actually demonstrate how we are going to brake this motor. By pressing this switch, we can bring the motor to a stop. And if we measure the voltage across this capacitor bank, then we will find that we have a certain amount of voltage stored here. And once we press this switch, then we can find that this voltage is used to light up this LED, and this is how we can generate usable electricity while braking this brushless DC motor. And this regenerative electric power supply comes from the back EMF that the brushless DC motor generates while rotating. Now let me show you a demonstration of how the electric load connected in parallel to this DC motor can actually bring the motor to a stop. So if the value of the load connected across this motor is actually high, then the motor will brake faster, as opposed to making it stop at a slower rate with a less amount of load. So now the LED is actually disconnected from this circuit. So the only load that is connected across this motor is the capacitor bank. So if I now press this button to make the motor to a stop, now let me show it at a higher speed. This motor is rotating quite fast, as we can see. Now if I bring it to a stop, then we can see that it takes a little amount of time. Now let me repeat this process with the same speed again, while having the circuit, having the LED connected across it. Okay. Now I'm going to repeat this process having this circuit, having this LED bulb connected Now until now I have done this only with the capacitor in the circuit. Now I'm going to do it with the LED connected as well. So this is how the motor, rotation of the motor. Now if I press this button to brake, we can see that the motor is actually stopping at a faster rate for the same speed. So here we can see that because of the greater amount of load, in this case when the LED is connected along with the capacitor, the motor comes to a stop at a faster rate. This is the circuit that we have implemented along with its diagram. So this is the actual circuit having the probes of the oscilloscope connected to the terminals of the two diodes. We have connected the oscilloscope in such a way so that we can observe the pulse width modulation wave in the oscilloscope screen, and we can see that here. The frequency, as we can see, is somewhere around 5.6 kilohertz, and the magnitude is approximately 10 volts. This is the speed versus output voltage graph that we have obtained by taking various readings of different frequency and the output voltage, and this is the Arduino code that we have used to generate the PWM signal. This is the schematic diagram of the circuit that we have implemented, and we can see that here a capacitor is connected along with the resistor R6. Here the resistor R6 can be equated with the LED bulb that we have connected in our actual circuit, and we can see that the rectifier set that we have used here is used to turn the pulse width modulation signal into usable DC, and this DC signal is actually stored in the capacitor temporarily until we use it. The demonstration that we have actually given in this video so far has been that of a motor without any sort of load, and that is why we saw that the voltage generated was not that great and the light only flickered for a small amount of time. However, if we didn't face the practical any of the hindrances that we faced, then we could have attached a greater amount of mechanical load to the motor that we have used here, and that would have created a greater inertia in the rotor of the motor, and because of this inertia it would have taken the motor a slightly longer time to come to a stop, and within this time the amount of voltage that could have been generated by the back EMF would have been greater. So if the mechanical load on the DC motor is greater, then the amount of voltage generated will also be greater. However, we faced this particular problem while actually making this project, that we were not able to attach a mechanical load to the rotor of this motor. This project can actually be implemented in various sectors, especially in case of electric cars, where we can brake the car and that energy spent in braking the car can actually be stored to power up the accessories of the car that require electrical energy. So while making the car come to a stop, we can use the back EMF generated by the DC motor or any sort of motor used by the car to light up the lights or power up other such accessories of the car. We can also use it in household application in case of our ceiling fans or any other fans in our household usage. So that's about it. Thanks for watching this for so long. Thank you.